Hello guys, welcome back. This is Dr. Paul. So today's video we're going to cover panel number 2 in the Korr 8. So panel number 2 is labeled ventilatory efficiency or equivalency, and which we're going to look at right now. So let's just jump right into it. In this video I hope to cover defining the ventilation divided by VO2 and the ventilation divided by VCO2, kind of go over the equation, define the metric that it's measuring, explain why it's called the ventilatory efficiency or equivalency. Some of the following videos I want to cover the common pattern of measurements and the common slopes that we see when we want to examine the slope from the aerobic to the anaerobic. We want to examine the AT for accuracy, and remember, all these videos are really just about trying to understand the measurements that are on these panels, because interpretation is obviously directly dependent upon correct understanding of the data and the accuracy of the data. So all we're trying to do is just basically understand what is actually in front of us, taking a good look at these panels. So let's move on to this. So we talked about panel 1 with some videos, and now we're into panel 2 on ventilatory efficiency. It's labeled ventilation divided by VCO2 versus time. Let's move into that. What is that panel actually? So let's pay close attention to the equation it has here. Ventilation divided by VO2 versus time. So we see time on the bottom, a measurement of time, and then we see this equation measuring both VCO2 and O2 all the way across this time period. We can see the graph has a downward slope here at the beginning. It almost looks inverted to the other panels that we're maybe used to seeing, and there's a reason for that. And so let's see if we can define that. So the first thing we want to notice is that the ratio, what is this actually? It's the ratio of the volume of air, so we notice it's air, not oxygen, just breathable air, the ratio of the volume of air ventilating the lungs to the volume of oxygen consumed. Here's the key line. It represents the amount of ventilation required for the consumption of each liter of oxygen, and thus reflects ventilatory efficiency. Sounds like a mouthful, right? So let's give ourselves a concrete view of this. So here is the air, and here is the oxygen. The air, there's 30 bottles or 30 liters of air in these bottles, let's say. And how many liters of air does it take to produce 1 liter of oxygen? And in this case we say 30 to 1. 30 liters of air to produce 1 liter of oxygen. That's why we might call it the equivalency. So the equivalent in this relationship is between the amount of inhaled air to the amount of oxygen extracted from that air. So a 30 to 1 relationship starts here. So if we come back and we take a look at this graph, we see, let's just use the O2, we see that it took 35 liters of air to produce 1 liter of oxygen up here. And of course it goes down, and we'll talk about that in our next video. And the same way here. It took 38, let's say, liters of air to produce a liter of CO2. So let's actually go look at the cardio coach and look at the calculator and maybe understand the root of what this actually is measuring. So I'm going to close this real quick, and I'm going to jump over to the cardio coach and throw our calculator up there. And oop, I already did that. I better just clear that. So if you're with me, notice that we're looking at ventilation here in liters per minute. Here's ventilation at 16.92. And over here is VO2, 482. This is in milliliters, notice. So let's notice that the equation is actually, if we look at it here, we'd see ventilation divided by VO2. So let's do that calculation. let's take ventilation, this first one, and let's do 16.92. So 16.92. And then notice it says we'll divide it against the VO2. Well, that's milliliters. So let's hit the divide sign. And since it's milliliters, let's put a decimal point there, and let's put 482, 482. And then let's see what the calculation is. It's 35 liters of air, 0.10, 35.10 liters of air to produce 1 liter of oxygen. And there it is right there, 35.10. Does it make sense? It's very simple. And so this tells us like what the efficiency is. It took this particular patient at the very beginning of the test, he was just breathing regularly 35 liters of air to produce that 1 liter of oxygen. And of course, it gets more and more efficient as it tends to drop down, which we'll see the usual pattern of increased efficiency, and then we'll see the loss of that pattern. So, it tends to increase in efficiency, and then it tends to kind of level off, and then at some point it will begin to lose its efficiency. So that is the ventilatory efficiency. We're actually measuring how efficient their body is extracting the O2 from their ventilation. So that's kind of where we're going to end, and we're going to pick up the next video, and we'll move on from there. Thank you so much. I look forward to getting back to you.